range Grifo 7 radar weighs 50 kilograms and its introduction on F-7M making it the first export version of F-7 series to be an all-weather fighter. This model is also first to be upgraded with a Chinese helmet-mounted sight, HMS, which greatly enhanced its lethality in dogfights. 46. All F-7 fighters delivered thereafter to Pakistan were equipped with such HMS. General designer Liu Yuying and Peng Renyuan. All 20 were delivered to the PAF on the 26th of July, 1988. 44-45. F-7P, further development of the F-7MP for Pakistan with a HTY-4 ejection seat. 2 more air conditioning outlets on the instrument panel to increase its efficiency. New RW replaced the LJ2 RWR. Grifo Mk2 fire control radar replaced Grifo 7 fire control radar on earlier F-7MP. In comparison to the Grifo 7, the new radar only weighs an extra 1 kilogram, 56 kilograms total, but the scan cone was increased to plus or minus 20 degrees from the original plus or minus 10 degrees off Grifo 7. The newer radar also had improved DCM and look-down forward/shoot-down capability, able track up to 4 targets simultaneously while engaging one at a time. Like the earlier Grifo 7, the Grifo Mk2 is also license-built by the ISO 9002 certified Camera Avionics Electronics and Radar Factory of the Pakistan Aeronautical Complex, PAC. Metrice instruments were changed to imperial units. Delivery of 40 aircraft to the PAF begun in September 1989. 44-45. Super 7, general designer was Tu Jida. After a successful deal with China in the early 1980s resulting in the F-7M, the United Kingdom offered further upgrades to improve the performance of the F-7M by adopting either General Electric F404 or Pratt & Whitney PW1120 turbofan engines. The radar options would include the Red Fox, a repackaged version of the Blue Fox radar used on Sea Harrier FRS Mk1, or the Emerson and /APG-69. All HALF radar tests were successful. The upgrade was rejected before any engine tests, because a single Western fire control radar or a single American engine would have cost more than a new J-7, $2 million United States dollars, 1984 price. 47-48. J-7 3 Series. The J-7 3 Series were the first J-7s to be equipped with fire control radar and thus the first all-weather fighter models of the J-7. However, due to the limitations of the Chinese avionics industry in the 1980s, the performance of the domestic Chinese fire control radars was not satisfactory. Due to their relatively larger size, the nose cone had to be enlarged, resulting in an increase in drag. As a result, only a few aircraft of this series were built. J-7 III, prototype of the J-7C, with a total of 5 built. Equipped with a domestically developed HTY-3 ejection seat and a KL-11 autopilot. Reverse-engineered MiG-21M obtained from Egypt, but just like the ejection seat, the original Soviet radar was replaced with a Chinese version. Designated as JL-7 and developed specifically for the J-7C. The JL-7 is a 2 cm wavelength monopulse fire radar weighing 100 kilograms, with a maximum range of 28 km and MTBF of 70 hours. Because of the failure of the WP-13F engine to meet the original schedule, the power plant was substituted for a WP-7. The general designer was Wang Shounan, later succeeded by Song Wenken. Planned to enter service in 1985, but due to the delay of the WP-13's development, it was not until 1987 when the design was finally certified. 4950. J-7C, renamed production version of the J-7 III powered by WP13F. Equipped with a Type 481 data link, which enables the ground-controlled interception centers to feed directions directly to the autopilots of the aircraft to fly hands-off to the interception. 51. The Type 481 data link was later included as standard equipment for all later models intended for domesticus. A total of 17 were built in a production run lasting from 1989-1996. 4950. J7IIIA, prototype of the J7D. The general designer was Wang Zifang. Equipped with a KJ11 autopilot, JD32 Taken, adds one air data computer, Type 563BINS, WL7A radio compass, Type 256 radar altimeter, TKR 122 radio, 930 4RWR, 941-4 decoy launcher and JL7A radar. Armed with PL7 and PL8AM and twin 23mm guns. The HK-13R had replaced HK-03D optical sight of the earlier models. The upgraded JL7A fire control radar added look-down forward/shoot-down capability. Equipped with a WP13F engine because FWP13F was not certified until October 1994. 5253. J7D, renamed production version of the J7IIIA with the WP13F engine. Initial certification received in November 1994, but it was not till December 1995 when the model was finally fully certified due to the need to certify WP13F on the aircraft. A total of 32 had been built when production stopped in 1999. 5253. F7C series. The F7C series is the first J7 series to adopt a side air intake design with the intention to house a more powerful radar in the nose cone. Project was started in 1985 but none entered production. The general designer of this series is Tujida. F7C, original successor of the Super 7 with side air intakes and a Chinese engine and avionics. Because the domestic Chinese aerospace industry in the 1980s could not provide a products on par with the West. Evolved into the F7CP after more than 3,000 wind tunnel tests. Kept as a cheaper alternative to the F7CP for a while before the cancellation of all F7C series. 5455. F7CP, with CP standing for China-Pakistan. Basically an F7C with Western avionics and engine. A 1-1 metal mock-up was built before development evolved into the F7S Sabre II. 5455. F7S Sabre II, successor to the F7CP jointly developed by CAC and Grumman. Compared to its predecessor, the air intake of the Sabre II forms a 10 degrees angle and the wings are changed to a trapezoid shape with leading edge extension, resulting in greatly improved aerodynamic performance. The plane was slated to use the General Electric and /APG-67 radar of the F-20 Tiger Shark. 5657. J7E series. J7E diagram. The J7E, NATO reporting name, Fish Candy, 58, is the day fighter series of the J7 that utilizes a double delta wing which greatly improved maneuverability from previous models. It was decided that in order to maintain good maneuverability, the series would not be equipped with fire control radar or medium-range AAMs. 5960, equipped with only ranging radar and close-range AAM. New features of this series included utilization of a carbon-carbon composite brake that quadrupled the service life to more than 1,000 landings. Utilization of an aluminum-lithium alloy that reduces weight by 17% and pressure ground fueling system, replacing the gravity-based ground fueling system that drastically reduced the time of fueling by 80% to 6 minutes from the original half an hour. 61. Deletion of the port side gun resulted in an increased fuel capacity by 100 liters. The ammo for the starboard side gun was reduced to 60 rounds. The WP-13F engine increased mean time between overhauls, MTBO, to 300 hours and the service life to 900 hours. 59. 60. Maximum payload is increased to 1.6 tons. Avionics replaced the older ones on earlier J-7s. The general designer of the J-7E series was Liu Yuying. J-7-4. Prototype of the J-7E with production of the prototypes begun in October 1987, and test flights completed in May 1993, 3 years after the testing started. In addition to other issues, the Chinese JT-1 had proved especially problematic and malfunctioned frequently during flight testing. 59. 61. J-7E, renamed production version of the J-7-4 with problems exposed by the prototype as being corrected, such as aileron flutter, automatic pitching, lateral Dutch roll, and the HUD. This model is equipped with a Chinese version of the Italian Pointer 2500 ranging radar originally used on the Q5M, modified to fit into the nose cone of the J-7E. Pointer 2500 ranging radar is a development of the Pointer ranging radar used on the initial production version of the AMX International AMX 62, which in turn is a licensed Italian copy of the Israeli L-M 2001B pulse Doppler ranging radar. 63. 64. More than 260 had been built when production ended in 2001. 59. 61. J-7EB, unarmed version for the PLAF, the 1st of August aerobatic team with B standing for Baoyang, meaning perform /show in Chinese. The gun, weapon pylons and fire control systems were deleted. 12 delivered in 1994, another 12 delivered between 1999 and 2000. All 24 are equipped with HTY6 ejection seats. After re-equipping the 1st of August aerobatic team with the more advanced J-7GB, all 24 J-7EBs were rearmed and returned to active service. 65. 66. J-7A, novelized version of the J-7E. Modifications include measures to counter salinity and humidity. 65. 66. J-7L, J-7E upgrade. Due to the inherent difference between the J-7E and its successor the J-7G, not all of the approximately 3 dozen improvements the J-7G has over the J-7E could be retrofitted to the J-7E during its upgrade cycle. Instead, only a small portion of the improvements the J-7G had over J-7E could be retrofitted to the J-7E. The most significant of these is the incorporation of the fire control radar of the J-7G to the J-7E, which gives the latter its all-weather capability. The L in the designation stands for laser, radar in Chinese, signifying the model is equipped with fire control radar. 67. 68. J/F7F series. J7FS diagram. J/F7F series is an alternative development to earlier F7C series in that it inherits the design characteristic of eliminating the nose intake, but instead of side intakes adopted by the F7C series, J/F7F series utilizes underchin intake. This series is mainly intended for research on underchin intakes and has not entered series production. J7F, JF7 program begun in 1995 and it is the first J7 designed to utilize underchin intake, which is identical to that of F8 Crusader. No prototype was built before the design evolved into J7FS.6970. J7FS, developmental technology demonstrator built by CAC as the successor of earlier J7F, with S stands for Shiyang, meaning experimental in Chinese. JF7 utilizes WP13IIS engine and a redesigned underchin inlet similar to that of Dout XF8U3 Crusader 3, with a divider inside the intake. The most obvious visual characteristic of the intake is that the bottom of the intake tends forward, thus forming an angle to the fuselage instead of being perpendicular to the fuselage like that of 8 Crusader and J7F design. First flew in 1998, only 2 prototypes were built before being replaced by J7MF.6971. F7MF, successor of the J7FS, with rectangular underchin inlet similar to that of the Eurofighter Typhoon, and movable canards for better aerodynamic performance. No prototypes were ever built before the project being abandoned in favor of the FC1.7273 MiG-21 upgrade subcontract. Romanian Air Force MiG-21 Lancer in 2012. In the 1990s, export of F-7 series had significantly dropped from its peak in the 1980s when China failed to secure any new orders in the decade. However, China was successful in completing 2 deals for MiG-21 and F-7 upgrades by Israeli Elbit Systems as its subcontractor, and experience gained from these subcontracting jobs enabled China to later develop more capable J-7 models. 74-75 MiG-21 Lancer. In the early 1990s, Elbit proposed MiG-21 Lancer for Romania as its bid to upgrade Romanian MiG-21. However, Russia refused to provide any technical data /information of MiG-21 that was necessary to integrate Israeli avionics to the Soviet airframe because the Israeli bid was in direct competition with MiG-21-93, Russia's own upgrade proposal. Elbit turned to China for help, and part of the deal between China and Israel was that China would receive technology transfer of Israeli avionics. 74-75. Eventually, Elbit beat the Russian and won the Romanian MiG-21 upgrade deal, and the first MiG-21 Lancer begun made its maiden flight on the 22nd of August, 1995. 76. MiG-21 Lancer A is the first model of MiG-21 Lancer family, and it is a ground attack version that is armed with Lightning electro-optic targeting pod. 76-77. A single MFD is added to the flight instrumentation. 78. Chinese electro-optical targeting pod based on Lightning is designated as DC-1. 79. MiG-21 Lancer C. MiG-21 Lancer C is the air defense version of the MiG-21 Lancer series. 76-77, with maiden flight on November 6, 1996. 76, equipped with L/M2032 airborne fire control radar. This model has 2 MFDs on its flight instrument. 78-80. In addition, to provide the technical data needed, the Research Institute for Special Structures of Aeronautical Composite of Aviation Industry Corporation of China, AVIC, also supplied the nose cone radar radome built of composite material. 74-75. More than one Chinese radar development houses have benefited from the technological transfer of L/M2032 radar, such as Nanjing Institute of Electronic Technology, which is also commonly known as the 14th Institute, China Electronics Technology Group. Corporation Number 38 Research Institute, which is also commonly known as 38th Institute, and of the Radar and Electronic Equipment Research Academy of Aviation Industry Corporation of China, AVIC, which is also more commonly known as the 607th Institute. MiG-212000 MiG-212000 for Myanmar, at the 6th Aviation Expo China held in Beijing, Albert